Hello, welcome to My Easy Statistics. Before starting this session, I want to share this information with you. Recently, I have prepared Mastering Structure Equation Modeling with Amos course. The course is designed from basic to advanced level topic in a simple and easy way to understand and do your data analysis. It is just rupees 1000 for lifetime access. You can purchase this course online from the link given in the description. Kindly share this information with other researchers also. In this video, we will discuss about bootstrapping, a powerful technique to handle non-normal data. SCM assumes that the data follows a normal distribution. So if your data is normally distributed, then there is no problem in the data, you can go ahead. But if the data does not follow a normal distribution, then it can result in higher chi-square values, which may lead researchers to make unnecessary adjustments to the model. And another issue with the non-normal data is that it can cause the model fit estimates to appear higher than their true values. So to handle non-normal data, bootstrapping is the best method. So if your data is having normal distribution, we can go ahead. If not, we need to do bootstrapping. Bootstrapping is a statistical technique where it repeatedly takes some samples from our data and creates a large sample. So we are thinking that if the data is not normally distributed and we do bootstrapping to a larger sample, then the data can be used to fit the model. But sometimes even bootstrapping method may not help the model fit the data. So we need to first check whether the bootstrapping the data will make the model fit. So to do this, we will employ Bollenstein method to see how well the model fits the data by using bootstrapping method. So if our data is not normally distributed, then we are thinking that doing bootstrapping will help us. Let us imagine I want to do bootstrapping to 5000 sample. Now we need to test with this Bollenstein method whether this 5000 bootstrap sample will fit the model with the available data. So to check this one, we need to do this Bollenstein method. Now I'll take to SPSS Amos. I'll show an example. We'll use this mediation analysis example. This example I have used in Mastering Structure Equation Modeling online course also. The same example I'm taking here and discussing for the bootstrapping purpose. Now, in this mediation analysis, first we are going to see, first thing is, what is the sample size? Second, we are going to see is whether the data is normally distributed or not normally distributed. Okay, if the data is not normally distributed, then we will decide to do bootstrapping and check with the Bollenstein method whether we can use this data or not. So first we are going to run the analysis. Let us see the sample size first. If you see this selected data file, here you can see the sample what we have is 384. Okay, now we will test this normality. For doing this normality test, we need to select this button, analysis properties. In this analysis properties, we need to select in the output, we need to select this test for normality and outliers. Okay, after selecting this, close this window and click on analysis properties, calculate estimates, and this view output path diagram. Now in the view text, if you click this button view text, we'll have here assessment of normality. Now here we got for each variable, for all the variables, we will have the skewness, kurtosis and critical ratios for skewness and kurtosis. If this critical ratio value is between minus 1.96 to plus 1.96, then the data is normally distributed. You can see all the values are beyond that limit. So the data is not normally distributed. You can even see the multivariate normality also. For this multivariate normality, the critical ratio is 30.857. If it is between minus 1.96 to plus 1.96, the multivariate normality is also there. But in this case, the data is not normally distributed. So the next we need to do is we are going to do bootstrapping for 5000 sample. We have at present 384 sample. From this 384 sample, we will make a bootstrapping for 5000 sample. And let us see whether that 5000 sample will be having the model fit with the data or not. For that purpose, close this window. Okay, click this input path diagram. Now again, analysis properties. In this analysis properties, select bootstrapping. In this, we need to do three important settings. The first one is perform bootstrap. Here we have 200 sample, make it into 5000. Okay, right, 5000, number of bootstrap samples are 5000. And select this bootstrapping ML, okay, maximum likelihood. And here you need to select the very important one, Bollenstein bootstrapping. So these three settings we need to do. One is perform bootstrap for 5000 bootstrap sample. Click this bootstrap ML and Bollenstein bootstrap. Now close this window, and now we are going to do calculate estimate. And click this button which is called as view the output path diagram. And let us go to view text. In view text, first we will see model fit. In this model fit, we can see the chi-square value. Chi-square value is 56.754. Now we will see bootstrapping distribution. In this bootstrap distribution, we have a limit. The minimum is 13.737, maximum is 91.50. But when you see the model fit, the chi-square value is 56.754. So this value is between this limit only. So this is a basic analysis where we can say that, okay, bootstrapping can be used for model fit. If the chi-square value is between this distribution of minimum to maximum, minimum is 13.737, maximum is 91.5. We got 56.754. So this is between the limit. So we can say that, okay, chi-square value is between the range of the distribution. So we can use this bootstrapping of 5000. Now let us see this Bollenstein bootstrap. Here we have interesting findings. In this Bollenstein bootstrapping, the model fit better is for 4706 bootstrapping. Means 4706 is the best for doing bootstrapping. That is the highest sample. The minimum, the worst one is 294. If you take 294, it will be the least one, worst one. The best one is 4706. So this is a limit of bootstrapping which we can use. We have 384. So this is between this limit only. Now let us see the assumption. You can read the statement. Testing the null hypothesis that the model is correct. Bollenstein bootstrap p-value is 0.059. If the p-value is more than 0.05, we'll accept this statement. The statement says that model is correct at that bootstrap sampling of 5000. So since we got 0.059, we are accepting that the model is correct. If this p-value is less than 0.05, we could have rejected it and said that this bootstrap sample cannot make the model fit the data. So this is the final conclusion. I hope this video will help you in your data analysis. Thank you.